Hi there. This video follows the introductory video on Cahn Ingold Prelog rules and also the introduction to chirality in organic molecules. Okay. In our discussion of chirality, you learned that molecules that contain asymmetric carbons, so that's a carbon with 4 different things arranged around it, have mirror image compounds which are not superimposable on themselves. Okay, these two forms are called enantiomers of one another, and molecules themselves are chiral. Okay. They have non-superimposable mirror images. Okay, and we've learnt in the Cahn Ingold Prelog rules how to assign the priorities of groups that are attached to chiral centers and stereocenters. Okay, so here is an arbitrary asymmetric molecule, okay, with a chiral center. We have 4 different groups attached, and then we've got a mirror in between them, and then this is its mirror image. Okay. And just as we've seen with naming double bond isomers, we can use Cahn Ingold Prelog rules to name these two enantiomers and to tell them apart. Okay, and the nomenclature we use is we have what's called an R and an S notation. Okay, so easiest thing to do is for us to work through this, assign the priorities as we would do, and then see what we get. Okay, and we'll explain things as we're going along. Okay, so we use Cahn Ingold Prelogs rules. Okay, I've kept these molecules deliberately simple. So the highest priority here is this chlorine atom. And then it's the nitrogen. Okay, so we're going down. Then we have the carbon here of the methyl group, and finally we have the hydrogen up here. Okay, so if I assign the same priorities over on the other side, just so that we're all typo, so that we're all got the same priorities. And assigning the numbers to these, you should understand, and you should know how to do this now from our discussion of Cahn Ingold Prelogs rules. Okay, so the first thing we do is assign priorities. So that's rule 1, assign the priorities of the groups that are attached. Okay. Now, the next bit is the bit that people have problems with. Rule 2 says rotate the molecule so that the lowest priority group is at the back. Okay. Now, people often have problems with this because they're not used to dealing in or thinking in 3-dimensional space. Okay. It's easier to do if you have a model kit available to you, but it will require some practice. Okay. Our lowest priority group is this hydrogen here. Okay. So what we're going to do is we're going to rotate this molecule so that the hydrogen is at the back. Okay, and we can do that by essentially bringing this amine up to the top and pulling chlorine round to the front. Okay, so if we redraw this molecule, okay, so I'm just going to redraw it with the molecule rotated. Okay, don't mind, I will get rid of this explanation box. Okay, so all I've done is rotate that molecule. Okay, so if you look, we've taken this amine and we've rotated it up to the top. In turn, that's pulled the chlorine round, and this hydrogen has been pushed to the back. Like I say, this is the bit that people have problems with. Okay. Now, the priorities are all still the same. Okay. So I'm just going to move the group priority numbers down so that we keep track of where we are. Okay. But the priorities haven't changed. Now we're going to rotate this molecule. Actually, forgive me, I will just do this. Okay, so we're going to take this molecule and we're going to rotate it. And when we do that, we're going to bring this amine up to the top. This chlorine is going to come out to the front. Okay. And the hydrogen is going to be pushed to the back. Okay. So when we do that, like I say, it's easier to do this if you've got a model kit available to you. Okay. It does require a little bit of practice in seeing models in three-dimensional space. Okay, so we've rotated this, the nitrogen is up to the top, the chlorine comes to the front, and the hydrogen is being pushed to the back. We've just effectively spun it on this bond here. Okay, and like as we did before, we'll just move the numbers because the priorities haven't changed at all. Okay, so we still have our mirror images. Okay. All we've got is the mirror images with the proton at the back now because we've rotated these molecules. Okay, right. The final thing that we have to do is assign what's called R and S. So R is clockwise and S is anti-clockwise. Okay, so we're looking at the priorities of these groups and we're going to say if they go clockwise then it's R, if they go anti-clockwise it's S. Okay, so here we have, on this one we're going from number 1 to number 2 to number 3. Okay, that is going anti-clockwise. So this one is S. Okay. This one we're going from 1, 2, 3. Okay. That is going clockwise, and therefore this is R. So we have anti-clockwise gives us S, and clockwise gives us R. Okay, so we've seen how to assign R and S on these simple molecules. Okay, we can extend these to thinking about more complicated examples. So if we talk about, for instance, a molecule that looks like this, for instance. Okay. Then we can bring in all the things that we've learnt from Cahn Ingold and Prelogs rules and assigning R and S. So here we have, the first thing that we do is we assign the priorities of the groups. Okay, so we have a chlorine, we have a carbon, and we have a hydrogen. Okay, chlorine has got the highest priority, number that number 1. Hydrogen's got the lowest priority, we number that number 4. Okay, we've got 4 groups of hydrogen. Now we've got to decide which of these 2 groups is the highest priority. This is carbon attached to one carbon. This is a carbon attached to one carbon, but it's double bonded to that carbon. So remember Cahn Ingold Prelogs rules, that double bonds are like having two of that atom attached. So this group here is higher in priority than this group here. Okay. The next thing we do is we rotate this molecule, and I'm going to redraw this, just rotating it. So we're going to spin the whole molecule round, okay, and we're going to bring the chlorine to the front, and we're going to put the hydrogen, as hydrogen is the lowest priority group, to the back. Okay, so we get this. Okay, and all we've done is just rotated that molecule. Okay, and I'm just going to move these numbers back across so that we can see what we're doing. Okay, and then we look to see if this is R or if this is S. Okay, so we have 1, 2, 3. Okay, we're going round that way, which is clockwise. And if it's clockwise, it is the R enantiomer. Okay. The R enantiomer. Now, if it had gone anti-clockwise, it would have been the S enantiomer. Okay. S is just Latin for sinister, which sinister means left in Latin, and R is Latin for rectus, which is right. So if it's going left, then it's sinister, S, and if it's going right, then it's rectus, is R. Okay, so here we're pulling in a few more of the rules from Cahn Ingold and Prelogs, and we're using it to assign R and S to this chiral center. Right. There's a lot of concepts that have been introduced over these last few videos. Okay, the most important one is to learn Cahn Ingold and Prelogs rules, and then you'll be able to apply those to assigning E and Z isomers and R and S isomers of chiral centers.